This is review quiz 3. So it's integration of rational functions by partial fractions. So we start by all the times simplifying the denominator in terms of factors, if possible. If possible. And we start by that step here because the numerator polynomial degree, it's smaller than the denominator polynomial degree. So we don't have to do the wrong division technique. So we have x squared plus 15x plus 26. So to find its factors, we can recall this is the form as ax squared plus bx plus c. And then if we were to do factorization method, this side of a and times c, it's 26, and b, it's 15. So we find factors of 26, which when you add them, you get 15, and that is 2 and 13. So x squared plus 15x plus 26 can be written as x squared, then 15x is the same as 2x plus 13x. So it's 2x plus 13x, the two factors that give you 26 when you multiply them, plus 26. Then you pair this and this. You factor out the common factor, which is x here. You get x plus 2. For the second part, you factor out 13, and then you have x plus 2 in the parentheses. That means that our integral now can be written as x plus 1 divided by the factors x plus 2 in the parentheses, and then the other one is x plus 13. And then we're integrating with respect to x. Now, to find the simple fractions or the partial fractions, you set whatever it's the integral to be equals to and determine coefficient A over the first linear factor plus another undetermined coefficient B over the other linear factor 13. Then you solve for A and B. That becomes, you multiply all sides of the equation by x plus 2. Let me show you x plus 2, x plus 13 on all the fractions. Same case applies here, x plus 2, x plus 13, because that's a common factor. That's the, yes, common factor. Multiply here by x plus 2, x plus 13. And that means that this can cancel, and this will cancel. You get x plus 1 on the left-hand side equals to x plus 2, you cancel with x plus 2. You have a and x plus 13 plus b. X plus 13 will cancel, you get x plus 2. Then you can decide to expand this equation and solve for a and b, or you can just do the choices of x's that will eliminate some undetermined coefficients. So if you are to choose x to be equals to minus 2, we have that minus 2 plus 1 is equals to a minus 2 plus 13, then plus b minus 2 plus 2. That gives you minus 1 equals to minus 2 plus 13 becomes 11 with an a, and then minus 2 plus 2 is 0. So this part becomes 0. So you have that A equals to minus 1 divided by 11. Let's solve for B. To choose for B, if you are to choose x to be equals to minus 13, you have minus 13 plus 1 equals to A minus 13 plus 13 plus B minus 13 plus 2. And then that means the part with an A goes to 0. And then this one becomes minus 11B. And on the right-hand side, we get minus 12. So this implies that if you divide by minus 11 on both sides, you get B equals to 12 divided by 11. So now you have the coefficients A and B. So that means if we integrate x plus 1, the way it was given, divided by x plus 2, x plus 13, with respect to x, in terms of simple fractions, is the same as integral. Our A is minus 1 over 11 divided by x plus 2. Can say split it, get dx plus integrate B, it's 12 over 11 divided by the other factor x plus 13 with respect to x. And by the integration, we have minus 1 over 11 integral of 1 over x plus 2 with respect to x plus factor out 12 over 11. Then you have the integral of 1 over x plus 13 with respect to x. And this will result to minus 1 over 11. The integral of 1 over a linear factor, it's natural log of x plus 2 because it's a linear factor, plus 12 over 11 natural log of the other linear factor x plus 13. Then don't forget to put a plus a constant c. So you can go ahead and simplify more further using the properties of natural logarithm, but I'll leave it at that point. Let's do the second one. Same thing, but this one, it has been simplified to two factors. One is linear factor. This factor here, it's linear because the highest power of x is 1, a linear factor. And this one, the highest power of x is 2, so it's quadratic factor. And that means we will have another arrangement of our simple or partial fractions. So we write the integrand 10 over x minus 1, that's 1, x squared plus 9. This will be equals to a for the linear factor over x minus 1 plus, now the quadratic factor, we will use bx plus c, then you divide here by x squared plus 9 because it's one quadratic factor. And then let's solve for a, b, and c, the undetermined coefficients. So what we do again, we multiply everywhere by the common factor, which is x minus 1, x squared plus 9. Same thing, x minus 1 everywhere by the common factor, x squared plus 9. And even the last part, x minus 1, it's multiplying that, x squared plus 9. And then you cancel what is common. So be left with 10 on the left-hand side equals to x minus 1. We cancel the x minus 1. You'll be left with a x squared plus 9 plus cancel what is common. You get now the remaining bx plus c, then multiplied by x minus 1. You can decide to choose choices of x that will eliminate bx plus c, this linear term. But I'd like now to use the second method, which is expanding, to show you the two steps, the two methods. So here you have ax squared plus 9a. I'm expanding plus, now the expansion here, if I was to FOIL, I'll have bx by x, that's bx squared, bx times minus 1, that's minus bx. Then c times x, that's plus cx. C times minus 1, that's minus c. And then you put the terms together. The coefficient of x squared, it's a plus b, because they have x squared. So you factor out x squared. The coefficients of x, it's c and a minus b. So you factor out x. And the constants, they don't have any x. It's 9a minus c. On the right-hand side, you only have 10, which is a constant. So meaning that the coefficient for x squared, you can write like this, x squared. On the right-hand side, we have a plus b. On the left-hand side, we have 0, because there's nothing on the left-hand side which has x squared. So the coefficient should be 0. The coefficients of x on the right-hand side, it's c minus b. On the left-hand side, again, we have nothing, so it's 0. And then the coefficient of the constant, we can say x plus 0, or the constants. On the left-hand side, the constant, it's 10. On the right-hand side, the constant, they don't have an x, it's 9a minus c. Now we have system of linear equations, the 3 of them. And this is easier because you can just you can solve for a. For the first one, a will be equals to minus b. For the second one, you can see that c equals to b. And the last one, you can see that c equals to 10 minus 9a. So if you take minus c, you have c equals to, sorry, minus 10 plus 9a. Now, c is equals to minus, use the last one. Let me put an asterisk on that. C equals to minus 10 plus 9a, but also c equals to b. So I can substitute c with a b. So this b comes there. Instead of c, I have a b. So b will be equals to minus 10 plus 9a. What else we know from the first one? It's that a equals to minus b. So instead of b, I can write minus a. So minus a equals to minus 10 plus 9a. And now I have an equation which has only a's. Now if I was to solve for a, I will have minus a minus 9a equals to minus 10. So this gives you an a equals to 1 if you solve for a. A equals to 1, and the 3 equations were these ones here, the one which was simplified, number 2 and number 3, the one with an asterisk. A equals to 1, and a is also equals to minus b. So a equals to minus b. So that means that b equals to minus 1 because they have a difference of a sign. Finally, c. C equals to minus 10 plus 9a, but a is 1, so it's 9 times 1. So you have c equals to minus 1 as well. So I am having the coefficients a, b, and c now, and I can solve the rational function, the integral of the rational function, 10 over x minus 1, x squared plus 9 with respect to x can be written in terms of these simpler fractions. A which is 1, divided by x minus 1. Then the other one is b is minus. So I can have plus here. I have a minus b minus x, and c is still a minus, so minus 1. All this divided by x squared plus 9, and then all that with respect to x. So now solving the right-hand side, I can split this into two integrals. So I'll be having integral of 1 over the linear factor 1 x minus 1 with respect to x. I can decide to factor out a minus, and I'll be having another integral now with positive x plus 1 divided by x squared plus 9 with respect to x. Now let's do the integration. For the first one, because it has a linear factor as a denominator, it's just natural log of x minus 1. I can say plus a constant, and let me call it a constant C1 minus. Now, observe that the second integral, it's x plus 1 divided by x squared plus 9. So x plus 1 can be splitted again into 2. And let me use parentheses. I'll have an integral of x divided by x squared plus 9 with respect to x plus another integral 1 divided by x squared plus 9 with respect to x. Now, the first integral, after we split, plus C1 for the first part minus this first integral here. It's a u substitution, because if you have to set u to be somewhere here, let's see, if you have to set u to be x squared plus 9, then derivative of u with respect to x, or it will be equals to 2x. So you multiply by dx all the sides. And now x dx in the numerator. To get an x dx, which is the numerator in terms of u, you just divide by 2 both sides. So giving u du over 2 equals to x with respect to x. That means that in my parentheses, I'll be integrating a function of u, which is numerator is du over 2, so I can factor out a half, and then the denominator, it's u. Then plus the integral here, it's a special integral, which we have learned that the integral of 1 over x squared plus a squared, let me mention here, the integral of 1 over x squared plus a squared with respect to x is equals to 1 over a arctan or tan inverse of x over a plus a constant c. So that one, I'll go ahead and write, it's 9, it's 3 squared, so a is 3. So 1 over 3 arctan or tan inverse of x divided by 3. And then plus a constant c. So what is left now? Another constant, because it's constant c2, because I have a c1. So what's left, it's now to do the u substitution. And then we do the integration plus c1 minus a half natural log of u. But our u was equals to x squared plus 9 plus, no, a minus, because of the minus sign, minus a third arctan x over 3 or tan inverse plus another c. Let me say minus, but still it's a constant. Let me call it plus c2. So finally, I can give the answer as a natural log of x minus 1 minus a half natural log of x squared plus 9 minus a third arctan of x over 3 plus a one big constant, let me call it capital C. That should be the answer, but you can simplify using the properties of natural logarithm. So be having natural log of x minus 1 divided by the square root of x squared plus 9, then minus a third arctan x over 3 argument, then plus a constant c. That's the end of the recitation for the review quiz 3.